Hey there, this is exercise 14 or worked example 14 on piecewise functions. So the function here is defined by this statement. So it's f of x, function of x is x squared for x is less than 1, and it's minus x for x is greater than or equal to 1. Question A requires us to find function of minus 2. So looking at the defined function, we know that minus 2 is less than 1, so we're going to use the first equation. So it will be minus 2 all squared, which is 4. So that's our first answer for part 2, function of 1. Now that is on the cusp of these two functions, but the equals greater than or equal sign requires us to use negative x. So that would equal negative input, which is negative 1. So that's it there. And 3, for completeness, they've obviously given us one that is squarely in this range here, greater than or equal to 1. So that's what 2 is. So that would be negative 2. We'll just leave it like that, okay? So we've evaluated that. Function of negative 2 equals 4. Function of 1 equals negative 1. And function 2 is negative 2. Okay, so I've just written explicit statements to answer those questions there. Now we're going to sketch and show the domain and the range. So let's sketch the x squared function first. There is a defining point or overlap when x is 1. So I'm just going to circle 1 here with my little pen just to hold that space. It's a straight, so the first graph, y equals x squared, is a straight parabola, has origin here, 1 out, 1 up, another out, another 3 up. So I'm just going to do some points for it. I know it stops at 1, so I'm just going to stop my graph here at 1, 1. It is less than 1, hence the open circle. So I'm just going to keep that as an open circle. It's nearly closed, but it should be open. Okay, the next function, of the next piece of that overall function is y is negative x. I'm just going to sketch that line there. We have no shift in the intercept, which means the line goes through 0, 0 here. Oops. Okay, so 1 point on that line is 0, 0, but that's to the left of our x equals 1. So I'm just going to do it very lightly in the origin there. Negative x means it's a negative 1 gradient. So here, 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 here. Greater than or equal to means that 1 is a member of that graph. So we do a solid line there. And we continue x is great when the domain is greater than negative 1, like that. So I've drawn it in 2 different colors. However, that is the piecewise function drawn. So let's just write that on the graph. We're just going to write f of x equals to x squared, or negative x squared when x is less than 1, and this one when x is greater than or equals to 1. So that's our label, and that's just for doing really good graph labeling there of that particular function. Next question asks us to state any value for, we've got to state the domain and the range, so let's do that next. So B, we've done B there, and let's finish B over here, the domain. Such as x is an element of real numbers, 1 is part of it, so we don't need to do anything further, and the range is similarly, x is an element of real numbers also. I think that's okay. Your book actually says that the range goes from so let's just write down what the book says. Negative infinity up to negative 1, unioned with 0 to infinity. Got ya. Okay, so rightfully so, they're acknowledging that the discontinuity in here between -1 and y of 0. Okay, part C, we're going to finish off here. State any value for x which a function is not continuous. That's for x equals to 1 because there's a drop. I'm going to put ramp or drop. Okay, that one's done.